Hello folks, we are going to look now at the second exponent fact. First, let's review exponent fact number 1, where we have a product of powers in the same base. So we have some power, the mth power of x, multiplied by another power of the same base x. In that case, we add the exponents. And so we saw some examples. For example, if we had x to the 8th times x to the 4th, that would be x to the 12th. Adding the exponents, the base stays the same. Likewise, if we had 2 to the 8th times 2 to the 4th, that would be 2 to the 12th, which is 4,096 using our calculator. What we're going to look at this time is when we have a power of a power. So, for example, suppose we have, let's say, x to the 3rd, and that power is being raised to another power, x to the 4th. Well, the 4th power of anything means you take that base and you multiply it by itself 4 times. So this time x to the 3rd gets multiplied by itself 4 times. Well, each of those x to the 3rds is 3 x's multiplied together. And so we see that we have 4 groups, and each of those groups has 3 x's multiplied together. And since we have only multiplication, we no longer need the parentheses. And if we count how many x's we have 12 x's all multiplied together. And so the base is x, and the exponent is 12. We have 12 x's all multiplied together. The key here, though, is really in this line, realizing that what we have is 4 groups of 3 x's all multiplied together, and therefore we have 12 x's multiplied together. But 4 groups of 3, that's multiplication. So x to the 3rd to the 4th is x to the 4 times 3 power, or x to the 12th power. We multiply the exponents. So our first exponent fact said that when we have a power times a power in the same base, we add the exponents. Now we have discovered that if we have a power being raised to a power, we multiply the exponents. So let's look at some examples. So x to the 3rd to the 4th power is x to the 4 times 3, or x to the 12th power. X to the 5th to the 4th power would be x to the 4 times 5, or x to the 20th power, because we have 4 groups of 5x's all multiplied together. X to the third to the 9th power, that would be 9 groups of 3x's all multiplied together. So x to the 9 times 3 power, or x to the 27th power. Now we want to keep our two exponent rules organized in our head. So remember, if we had x to the third times x to the fourth, now we have 3x's multiplied together, and then we're multiplying by 4 more x's multiplied together. So in this case, we add the exponents. As compared to in problem 1, when we have a power of a power and we multiply the exponents. So if we had x to the 5th times x to the 4th, that would be, that would be x to the 5 plus 4 power, or x to the 9th. Usually, we just do the adding or multiplying in our head, and we'll talk about that in a second here. So if we had x to the third times x to the 9th, that would be x to the 3 plus 9, or x to the 12th power. So make sure you compare the examples in the first row, problems 1, 2, and 3. That's our new exponent fact number 2, compared to the problems in the second row, problems 4, 5, and 6. That's using exponent fact number 1. Now, we can combine those problems, or we might have a problem where we have to simplify an expression, and maybe we have to use both of the properties, both of the facts. So for example, we might have x to the 10th being raised to the 5th power, and then that's being multiplied by, say, x to the 4th power. So we use our second property first, the power of a power. We're going to multiply those exponents, because if we wrote this out, we'd have x to the 10th times itself 5 times. So we'd have 5 groups of 10 x's multiplied together. So x to the 50th power. Then we're multiplying by x to the 4th. So we have 50 x's multiplied together and 4 more x's multiplied together. So in this case, we're going to add our exponents, and we'll have x to the 54th power. Maybe in another example, we have that same first factor, the 5th power of the 10th power of x, but then times, let's say, the 3rd power of x to the 4th. So a power, x to the 10th, being raised to another power, the 5th power, we'd have 5 groups of 10 x's multiplied together. So we're going to multiply the 5 and the 10, and we get x to the 50th, times the 3rd power of x to the 4th. So we'd have x to the 4th times x to the 4th times x to the 4th. 3 groups of 4 x's multiplied together. We'll multiply the 3 and the 4, those exponents, and the base stays the same, x, and we have x to the 12th. And now we're multiplying powers in the same base. We've got 50 x's times 12 more x's, so x to the 62nd power. Then we can make the problems even a little bit more complicated by throwing in different bases. Notice that between the parentheses after the exponent, there's nothing written, so that means that there's multiplication, not addition. It's only multiplication. In the first factor, we have the 5th power of x to the 10th. So that'd be x to the 10th times itself 5 times. So that would be 5 groups of 10 x's multiplied together. So the base is going to stay the same. We have a whole bunch of x's multiplied together. 5 groups of 10 of them would be 50 x's multiplied together. So we multiply the exponents, 5 times 10. Likewise, y to the 4th, then raised to the 3rd, that would be y to the 4th times y to the 4th times y to the 4th. 3 groups of 4 y's multiplied together. So we'd have 12 y's all multiplied together, y to the 12th. And likewise in the last factor, x to the 56th power. 7 groups of 8 x's multiplied together, x to the 56th. This time though, since we have different bases, we can only multiply powers that have the same base. So at least in our head, we need to rearrange the factors to put the factors with the same base next to each other. Now we're going to add those exponents, and then we'll leave the y to the 12th alone. So why did we add the exponents on the x's? Because this time we have 50 x's multiplied together, followed by 56 more x's multiplied together. And we might have similar problems where we have not only x's and y's or whatever variables being multiplied to powers, but we also maybe have powers of numbers in our problem. So again, notice that in between the parentheses there's nothing written, so we need to remember that that's multiplication in between. So first of all, the 5th power of 3 to the 2nd, a power to a power, we multiply the exponents. 5 times 2 is 10. So we'd have 10 3's all multiplied together. Then x to the 10th being raised to the 4th power, that would be x to the 10th, x to the 10th, x to the 10th, x to the 10th. So we'd have x to the 40th, multiplying the exponents. Likewise, times y to the 28th, multiplying those exponents, times 3 to the 6th, multiplying those exponents, times x to the 72nd, multiplying those exponents. Then we're going to rearrange the factors because we have multiplication. We can do this. And we're going to put our factors that have the same base next to each other. And with our variable factors, we're going to put those in alphabetical order. So 3 to the 10th power times 3 to the 6th power. So that's a whole bunch of 3's, 10 of them multiplied together, multiplied by 6 more 3's multiplied together. So that's 3 to the 16th. We're going to add those exponents. Notice that it's 3 to the 16th, not 9 to the 16th. We have a whole bunch of 3's multiplied together, not a whole bunch of 9's multiplied together. The base stays the same when we're multiplying powers in the same base, and we add the exponents. Now, the only question that remains is whether or not the 16th power of 3 is going to fit in our calculator, or if that number is going to be too big for our calculator. So the base is 3, the exponent is 16. And if we multiply that out, we get a huge number, 43,046,721 times x to the 112, y to the 28. We have a couple more exponent facts that we're going to talk about today in the next couple of videos.